For this example, we're after finding angle theta where we know 3 sides of the triangle. We don't know any of the angles, and as such we can't use the sine rule as we don't have any side angle opposite pairs. Knowing 3 sides, however, does mean we can use the cosine rule, which is given on the formula sheet. The only important thing is that I choose the correct angle here. So my angle A has to be the one I'm trying to find. Opposite that then has to be little a. So the 4 has to be little a. The B and the C, it doesn't matter. They just have to be the adjacent sides to the angle that you're trying to find. So we take our cosine rule and sub in what we know. A is 4, B is 10, C is 9, B and C again, and then cos of A is cos theta. And here we're going to need to do some rearranging. So first of all, take away the 10 squared and the 9 squared from both sides, giving us 4 squared minus 10 squared minus 9 squared. Importantly, that does still leave minus 2 times 10 times 9. That often disappears, very common mistake for candidates to make. Times 10 times 9 times cos theta. To get cos theta on its own, then we need to divide through by negative 2 times 10 times 9. So that gives me this rather complicated fraction. And just like inverse sine, our inverse cosine we can write as r cos. And that will save us problems later on over writing cos to the minus 1. From there, we can enter this all into the calculator. On the calculator, you do have to use cos to the minus 1. So 4 squared minus the 10 squared minus 9 squared. This is obviously faster for you to type in. All over 2 times 10 times 9. And close the brackets. And that gives us an answer of 23.5564 or 6, so on. It's an angle that we're trying to find, so if there is no guidance, 1 decimal place is what you should give your answers to. So here it's going to be 23.5, but because of the 5 after the 5, that's going to round the first 5 up to a 6. So my answer is 23.6 degrees.